Welcome to the DIY Honda Garage channel. DTC P2135 indicates a malfunction in the throttle position TP sensor AB circuit, specifically identifying an incorrect voltage correlation between these sensors. The TP sensors are essential components located on the throttle body, responsible for monitoring the position of the throttle plate. This data is crucial for the engine control module, ECM, or powertrain control module, PCM, to adjust the air-fuel mixture appropriately, ensuring optimal engine performance. A malfunction can lead to performance issues, affecting throttle control and possibly leading to drivability concerns. Before delving into troubleshooting, vital data should be recorded, ensuring a precise understanding of the issue at hand while reviewing any existing onboard diagnostics is essential. The Throttle Position Sensor, TPS, is a critical component situated on the throttle body of the Honda Accord. Its role is to monitor the position of the throttle plate, translating mechanical movement into an electrical signal sent to the ECM/PCM. This signal informs the engine management system how much air the engine should receive to optimize performance and adapt to driving conditions. The TPS operates in a range from fully closed to fully open, providing the ECM/PCM with continuous feedback. The malfunction indicated by DTC P2135 arises when there is a discrepancy between the voltages reported by the two sensors, TP sensors A and B. Such discrepancies can lead to suboptimal performance, hence requiring immediate analysis and potential corrective action. The potential causes for the DTC P2135 can vary, but generally include a few critical areas. A faulty throttle body may fail to operate correctly, leading to erroneous feedback to the ECM/PCM. Additionally, damaged wiring or loose connectors can disrupt the flow of information between the TP sensors and the control modules. Corrosion, moisture, or wear can further contribute to connectivity issues. Lastly, a malfunctioning ECM/PCM may not interpret the signals from the TP sensors accurately, resulting in a failed correlation. These factors must be thoroughly examined to identify the root cause effectively and restore proper vehicle functionality. The symptoms arising from the DTC P2135 include multiple performance-related issues. Drivers may experience poor acceleration response, as the throttle body may not open or function correctly due to inaccurate feedback from the TP sensors. Erratic engine behavior could manifest as fluctuations in engine speed or unintended acceleration, deceleration, which can be unsafe while driving. Additionally, the check engine light, CEL, will likely illuminate, alerting the driver to a problem within the throttle relationship and requiring prompt attention. Recognizing these symptoms is crucial, as they not only indicate a malfunction, but can also lead to broader performance issues if unresolved. Begin the troubleshooting process for DTC P2135 by turning the ignition switch to the on position. This step powers the electrical components necessary for diagnostics. Once the ignition is on, clear the DTC using the Honda Diagnostic System, HDS, to reset any recorded faults and prepare for a fresh assessment. Following this, run the Electronic Throttle Control System, ETCS, test within the inspection menu of the HDS. This diagnostic test will help assess the functionality of the throttle system, and any issues identified here will guide further troubleshooting steps. Maintaining clear records of these diagnostics is vital for future reference and understanding the vehicle's condition. After performing the initial steps, the next course of action is to check for any pending or confirmed DTCs via the HDS. This check will indicate whether DTC P2135 is still present or if another code has emerged, suggesting further investigation. If P2135 is indicated, you should proceed to the next troubleshooting step. Conversely, if there's no indication, the issue may be intermittent, and the system could be functioning correctly at this moment. In such a case, it's prudent to inspect the throttle body and the connections to the engine control module, ECM, or powertrain control module, PCM, for any loose terminals or poor connections that could result in sporadic faults. Next, you will need to turn the ignition switch to lock 0 and disconnect the intake air duct connected to the throttle body. This action ensures that you can monitor the throttle plate's operation freely and without interference from the intake system. Once disconnected, turn the ignition switch back to on, 2, while simultaneously observing the throttle valve's operation. As you clear the DTC using the HDS, notice whether the throttle valve temporarily moves to its closed position. This observation is critical to determining whether the throttle body is functioning as expected and will influence the next troubleshooting steps based on your findings. Assessing the throttle valve's operation is crucial. If it does move to its fully closed position upon clearing the DTC, you should proceed to the next troubleshooting step. This indicates that the throttle system is responsive and likely functioning correctly. However, if the throttle valve fails to respond as expected, you must follow the next set of diagnostics to determine the underlying issue. It's vital to remain methodical to avoid overlooking potential faults, as any discrepancy here can lead to further complications in the engine management system. In this step, you will disconnect the ECM-PCM connector B. This connector, identified as 49P, contains crucial wiring for the TP sensors. Once disconnected, check for continuity between terminals B17 and B26 using a multimeter, as this will reveal whether there are any breaks or shorts in the wiring. B17 corresponds to the throttle position sensor A line, while B26 refers to sensor B. Proper continuity indicates that the wiring harness is intact. If there is no continuity, this points to a significant fault in the wiring, necessitating further inspection or potential replacement. Following the check of the ECM-PCM connector, disconnect the throttle body 6P connector to ensure thorough testing of the system. After detaching it, once again check for continuity between terminal B17 and B26 of the ECM-PCM connector. This repeated test helps determine if there's still a consistent signal pathway from the throttle body through the connectors back to the control module. If continuity is confirmed, it indicates that the wiring is likely intact. However, if continuity is absent, there may be a short in the wire, prompting the need for repairs to restore proper communication across the circuit. If continuity is established between terminals B17 and B26, and continuity is missing from the previous check, this indicates a short circuit between the wire connections. Repair the short between the ECM-PCM terminal B17, which supports the throttle position sensor A line, and terminal B26, corresponding to sensor B. Effective repairs will restore the appropriate voltage levels and correlations necessary for the system's operation. After addressing the wiring issue, reconnect all harnesses and connectors securely, preparing the vehicle for system tests. Ensuring that all connections are firm is crucial in preventing any future faults related to connectivity. If previous tests confirm that the throttle body is not functioning correctly, you will need to replace it to resolve the fault indicated by DTC P2135. Prior to removal, disconnect the necessary electrical connectors to ensure safety and prevent damage. Once the new throttle body is installed, reconnect all relevant connectors securely, reviewing each connection to affirm proper placement. A reliable installation is essential for maintaining the overall integrity and performance of the throttle system. After reconnecting, Move on to the next steps to reset the systems. To toggle the ignition switch back to the on position for the final checks and adjustments. Powering everything up is crucial to ensure that the newly installed components are recognized by the vehicle's systems. Utilizing the HDS, reset the ECM, PCM to clear any previous fault codes and, importantly, to allow the system to relearn its operational parameters. This reset is fundamental for recalibrating the throttle settings and ensuring optimal throttle response. After the reset, it's beneficial to allow the vehicle to run for a short period to observe if any issues persist. Conducting the ECM-PCM idle learn procedure is essential, following any repairs or adjustments made to the throttle system. This procedure helps the control module recalibrate its understanding of engine idle parameters, ensuring smooth idle performance. After the idle learn is executed, utilize the HDS once more to check for any pending or confirmed DTCs. If DTC P2135 is still present, further investigation into the connections and components around the throttle body and ECM-PCM should follow. Observing the vehicle's response during initial driving can also uncover any lingering issues linked to the replaced components. Upon completing the troubleshooting process for DTC P2135, it's vital to perform a final verification of all repairs made. Ensure that every connector is securely reattached, particularly those related to the throttle body and the ECM-PCM. Inspecting for loose connections during the final steps can prevent future occurrences of similar fault codes. It is also beneficial to take the vehicle for a test drive under varied conditions, allowing the throttle system to operate in real-world scenarios to ensure proper functionality. If any issues are detected during this phase, they will need addressing to avoid repeated diagnostics and disruptions in performance. To mitigate the risk of encountering DTC P2135 or similar faults in the future, regular inspections of the throttle body and associated wiring are essential. Conduct periodic checks of all electrical connectors, ensuring they're free from moisture and corrosion, which can compromise their integrity. Additionally, monitoring the throttle body's functionality during routine maintenance can highlight issues before they develop into significant problems. Following the manufacturer's service intervals for maintenance tasks promotes overall vehicle health and longevity. Lastly, keeping software updates for the ECM-PCM current ensures compatibility and effectiveness in handling potential faults. In summary, DTC P2135 indicates an error related to the throttle position TP sensor's voltage correlation, necessitating a carefully structured diagnostic approach. Coverage of initial testing, inspections, and component replacements is essential to pinpoint and rectify the issue effectively. Throughout the troubleshooting process, reliance on diagnostic tools such as the HDS and performing continuity checks provides clarity in resolving possible faults. Additionally, implementing preventive measures helps reduce future occurrences of similar errors, enhancing overall vehicle reliability. By adhering to these detailed steps and maintaining awareness of routine vehicle care, drivers can ensure their Honda Accords perform at their best. Please like and subscribe to the channel. See you next time.